Okay, so the last issue for ionic naming is polyatomic ions. And I wanted to just show you real quick, there's a nice table in your book, it's on page 68 here in the 6th edition, of a list of the common polyatomic ions you would be expected to know for this class. I posted a similar list as a PDF file on the Moodle page. It might be a little more convenient because you can print that one out and just have it as one page while you're practicing. But you can get an idea of the polyatomic ions you are supposed to be aware of from the textbook. And what I'm going to do here is go through a few examples. And as you can see, I had to start over. So this is take 2 of the video because my recording device decided to switch to a portrait orientation when I was trying to zoom in on that particular table, and then the whole thing was facing the wrong direction to be able to see what was going on. But anyway, we're looking at polyatomic ions, and just as an example, poly means many, right, and atomic refers to atoms. This is a grouping of several atoms. Right? An ion means it has a non-zero charge. So we could have a grouping of atoms with a positive charge would be a polyatomic cation. A grouping of atoms that carry a negative charge would be a polyatomic anion. Now, there's really only one common polyatomic cation that we're going to encounter, particularly in naming ionic compounds, and that's ammonium. So NH4, so 1 nitrogen, 4 hydrogen atoms combined, will end up having a positive charge. This is called ammonium. So it's got IUM at the end, which is kind of a reference to, it's kind of like a metal. Metals take on a positive charge. This is a grouping of atoms that takes on a positive charge. So this is ammonium. Now, because of the positive charge, this will bond to anions, right, primarily nonmetals, in a fashion very similar to other +1 cations like we saw sodium and lithium. So we can make a compound between ammonium and, say, chlorine, one of each, because +1 -1, that would be ammonium chloride. So again, the cation comes first in the name, right? Even if there's no metal, we put cation then anion. If we use an anion that has, say, a -2 charge, like sulfide, so ammonium being +1, sulfide being -2, right? To balance the charge, there'd have to be 2 ammoniums in there. Whenever we have more than one of a polyatomic ion in a formula, we have to designate it as such by putting parentheses around the polyatomic ion and then making sure that that subscript is outside the parentheses. So the 2 now is referring to the polyatomic ion within the parentheses, but we need 2 ammoniums with 1 sulfide to balance this out. Now this would still just be ammonium sulfide, right? But it's very different than if we don't put the parentheses, because if you do this and then put the 2 and then put the S, that looks like 1 nitrogen, 42 hydrogens, and a sulfur, which is not a thing, and certainly is not the same as what we're trying to describe over here. So if there's ever more than one of the polyatomic ion, make sure you put the parentheses. Right? Now, just like we did for transition metals, I kind of wrote out a few of these to practice. So we'll go through a couple formulas and try to turn those into names, and then a couple names, try to turn those into formulas. But keep in mind, particularly with the polyatomic ions, you've got to make sure you've practiced enough. I think the way to really get these to stick in your head is to practice, to do it, to do it, to do it, and then eventually you know what nitrate is, you know what sulfate is, you're not really thinking about it. What some students will try to do is memorize the list. That's not quite the same, because we really need to put it into action. You need to pull it out of the formula here, or take the name and incorporate it into a formula here. So just sitting down with the list and saying, oh, NO3 minus, that's nitrate, NO2 minus, that's nitrite, right? That's maybe not quite what you need to do to be ready for the test. Okay, this first one, Na is sodium, SO4 is a polyatomic ion. In this case, that is the sulfate polyatomic ion. So this is sodium sulfate. And that's it. That's all we need for that one. But again, you've got to recognize that grouping, that it has this particular name. Now, in the second example, similar here, we've got to recognize the polyatomic ion. But in this case, we're going to have to be more concerned about the charge, because the metal here is chromium. That's in the transition metal series. That means we're going to have to specify its charge. So we're going to have to figure out the charge on chromium by knowing what the appropriate charge on this polyatomic ion is. This is carbonate. CO3 is carbonate, and carbonate carries a 2- charge. Now, I actually wanted there to be a 3 here on carbonate, so let me change that real quick, right, and make sure you note that if you're copying this down, that should have been a 3 there. Carbonate has a -2 charge. If there's 3 of them, that would be a total of -6 coming from the anions here. And that means there's a total of +6 spread over the 2 chromium atoms that are in this formula, right? +6 spread over 2 atoms means each one would be +3. So the chromium here would have a +3 charge. That makes this chromium 3 carbonate. Okay, so again, you have to not only recognize the name there from that grouping of atoms, but in a lot of cases you'll need to know its charge as well to figure out exactly what the name should be, particularly with a transition metal. Okay, a couple of examples with formulas, names, where we want to provide the formulas. And I like to do these in 2 steps, right? Just identify the charges first, then you're going to have to ratio the charges to get the right name. Cobalt-2 means this is a cobalt ion with a +2 charge. Cyanide is a polyatomic ion, but we know that it's a capital C, capital N, 1 carbon, 1 nitrogen, and that it has a -1 charge. And now if this is +2, this is -1, that means I need 2 cyanides in my overall formula to balance the charge. So 1 cobalt, since there's 2 cyanides, I'm going to put that nest of parentheses around it, and I'm going to put the 2 outside the nest. So the proper formula for cobalt-2 cyanide would be this one. Capital C, lowercase o, parentheses, capital C, capital N, N parentheses, and then the 2. Okay. Niobium-5 nitrate, similar issue here. Niobium has a +5 charge in this particular compound, but nitrate's a polyatomic ion. Nitrate's NO3. It has a -1 charge. So in this case, to balance out the charges, I need 5 nitrates. So 1 niobium, but then nitrate goes in parentheses, and the 5 needs to go outside the parentheses. Okay, so I don't know that it's any more complicated than what we did in the previous sections for ionic naming. It just adds the extra hurdle of needing to know what your polyatomic ions are. But as far as balancing charges and that sort of thing, it's really just more of the same. So make sure you practice those. Plenty of resources at the end of the chapter and plenty of resources in your textbook. Well, those are both in your textbook. Plenty of resources on the Moodle page as well. I've posted several practice worksheets that will just help you get that drill you need for naming. One more issue for chapter 2, naming a different type of compound. We will cover that in the last of the chapter 2 videos.